What if everything you think you know about reality is backwards? What if time, not space, is the true foundation of our universe? And what if time itself has 3 dimensions, not just one? A groundbreaking new theory from physicist Gunter Klitschko is turning physics upside down. And it's so precise, it can predict particle masses with mind-blowing accuracy. This isn't just theoretical speculation. This could be the key to solving the biggest mystery in physics. Today, we're diving into a theory so radical, it makes science fiction look conservative. By the end of this video, you'll never think about time the same way again. Let's start with what we think we know. Right now, physics tells us we live in a 4-dimensional universe, 3 dimensions of space up and down, left and right, forward and backward, plus 1 dimension of time that flows steadily forward. This is Einstein's spacetime, and it's been the foundation of modern physics for over a century. But what if we've got it completely backwards? Enter Gunter Klitschko, an associate research professor at the University of Alaska Fairbanks, who published a theory in April 2025 that's making physicists do. His radical proposal: time is the primary fabric of reality, and it comes in 3 dimensions, while space is just a secondary effect like paint on a canvas. Here's Klitschko's game-changing analogy. These 3 time dimensions are the primary fabric of everything. Like the canvas of a painting, space still exists with its 3 dimensions, but it's more like the paint on the canvas rather than the canvas itself. Think about that for a second. We've always thought of space as the stage where time plays out, but Klitschko is saying time is the stage, and space is just what happens on top of it. So what does 3-dimensional time actually look like? Klitschko gives us this mind-bending thought experiment. Imagine you're walking down a straight path that's our familiar forward-moving time. Now, picture another path crossing perpendicular to yours. If you could step onto that sideways path while staying in the same moment of regular time, you might find things slightly different, maybe a different version of the same day. Moving along this second path lets you explore different outcomes without going backward or forward in time as we know it. The existence of those different outcomes is the 2nd dimension of time. The ability to transition between these outcomes, that's the 3rd dimension. Now here's where this gets really exciting. Unlike previous 3-dimensional time theories that were just abstract mathematical constructs, Klitschko's framework actually works with real data. His equations can reproduce the known masses of fundamental particles, electrons, muons, quarks with incredible precision. We're talking about calculating the mass of the top quark at 173.21 plus or minus 0.5 G. That level of accuracy is unter. Coincidence? It's evidence that this theory might be describing something real about our universe. Earlier 3D time proposals were primarily mathematical constructs without these concrete experimental connections. Klitschko explains, "My work transforms the concept from an interesting mathematical possibility into a physically testable theory with multiple, independent verification channels." This is huge, because the origin of particle masses has been one of physics' biggest unsolved puzzles. Even the Higgs boson discovery didn't fully explain why particles have the specific masses they do. But wait, it gets even more mind-blowing. This 3-dimensional time framework might finally explain some of quantum mechanics' weirdest phenomena. Take quantum superposition, how particles can exist in multiple states simultaneously until measured. In Klitschko's model, what looks like superposition might actually be particles navigating different time dimensions rather than different states in a single timeline. Quantum entanglement, where particles remain mysteriously connected across vast distances, could be explained by deeper temporal connections through these hidden time dimensions, instead of faster-than-light communication. Entangled particles might be linked through the underlying temporal infrastructure we can't directly perceive. This could be the bridge physics has been desperately seeking between quantum mechanics, Einstein's relativity, two incredibly successful theories that have stubbornly refused to play nice together. You might be thinking, haven't physicists proposed extra time dimensions before? Yes, they have. Theoretical physicist Itzhak Bars at USC notably suggested that additional time dimensions become apparent at extreme energy levels, like during the early universe. But here's what makes Klitschko's approach revolutionary. It's testable. Previous theories were interesting mathematical exercises that couldn't be verified experimentally. Klitschko's framework makes concrete predictions about particle properties that we can actually measure and verify. His theory also maintains cause and effect relationships, avoiding the paradoxes that plagued earlier multidimensional time models. If Klitschko is right, we're looking at a complete paradigm shift. This isn't just tweaking existing physics, it's fundamentally reconsidering what reality is made of. The path to unification might require fundamentally reconsidering the nature of physical reality itself. Klitschko states, this theory demonstrates how viewing time as three-dimensional can naturally resolve multiple physics puzzles through a single coherent mathematical framework. We're talking about potential experimental verification through refined particle mass measurements that reveal new patterns, quantum entanglement experiments, testing correlations across non-traditional temporal parameters, and cosmological observations that might hint at temporal asymmetries in the early universe. So there you have it, a theory that flips reality inside out, where time becomes the canvas and space becomes the paint. A framework so precise it can predict particle mass, so comprehensive it might unify quantum mechanics and gravity, and so testable it could revolutionize physics within our lifetimes. Whether Klitschko's three-dimensional time theory proves correct or not, it's pushing the boundaries of how we think about reality itself. And that's exactly what great science should do. What do you think? Could time really have three dimensions? Does this theory blow your mind? Or do you think there are flaws we haven't considered? Drop your thoughts in the comments. I read every single one, and the discussions you start often inspire future videos. If this video rewired your brain even a little bit, smash that like button. Subscribe for more mind-bending science content, and ring the notification bell so you never miss when we dive into the deepest mysteries of our universe. Thanks for watching, and remember, reality might be stranger than we ever imagined.